In this video, we solve a polynomial degree 4 with real coefficients. The two solutions are looking like c plus I and 2 plus di, and we need to find a and b. Since the coefficients are real, the solutions come in conjugate pairs, as we explained already in our previous video. So c minus I and 2 minus di are solutions too. Polynomials can be written as a product of factors using the solutions alpha 1, alpha 2, alpha 3, etc. and can be visualized using the x-intercepts of our polynomial as the real solutions. The interesting thing is that there is a link between the sum of the n solutions and the coefficients of the polynomial. The product of the solutions is also linked to the coefficients. The sum is the opposite of the quotient between the second and the leading coefficient. The product is minus 1 to the n times the constant term over the leading coefficient. In our example, the sum of the solutions is negative minus 10 over 1, and the product is minus 1 to the 4, which is positive 1, times 50 over 1, which is 50. Adding the 4 roots, the imaginary parts cancel each other out, and we obtain the expression 2c plus 4, which equals 10. 2c must be 6, so c equals 3. The product of the 4 solutions is 50. Multiplying c plus I times c minus I leads to c squared minus I squared. Remember that when we square the imaginary unit, we get minus 1, so c squared minus I squared is c squared plus 1. Similarly, multiplying 2 plus di times 2 minus di leads to 4 plus d squared. The expression for the product is c squared plus 1 times 4 plus d squared, which equals 50. Substituting c equals 3 into the equation, 3 squared plus 1 equals 10. So 4 plus d squared must be 5. D must be 1. The 4 roots come in conjugate pairs, and they are 3 plus I, 3 minus I, 2 plus I, and 2 minus I. Explore this playlist to learn more about conjugate pairs, and until next week, happy learning!